नमस्कार एमएससी स्टूडेंट। आज हम डिस्कस करने जा रहे हैं बी एमएससी पार्ट सेकंड, या हम कहें फाइनल एमएससी फाइनल ग्रुप थ्योरी के पेपर हम डिस्कस कर रहे थे। आज हम डिस्कस करेंगे इन्वर्जन सेंटर और पॉइंट ऑफ सिमेट्री। अ पॉइंट प्रेजेंट इन द मॉलिक्यूल इज सेड टू बी इन्वर्जन सेंटर और पॉइंट ऑफ सिमेट्री इफ a line is drawn it against it means two same atoms at the equal distance from it in opposite direction। यानी कि एक लाइन यदि किसी पॉइंट मॉलिक्यूल में ऐसा कोई पॉइंट जिसके अराउंड एक लाइन को यदि ड्रॉ किया जाए और ये लाइन अपोजिट और इक्वल डिस्टेंस पे सेम एटम से या ग्रुप ऑफ एटम से मिलती है, तो मैं कहूँगा पॉइंट जिसके थ्रू लाइन खींची गई है इट इज़ इन्वर्जन सेंटर और पॉइंट ऑफ सिमेट्री। ये इन्वर्जन सेंटर और पॉइंट ऑफ सिमेट्री कहलाता है। द पॉइंट प्रेजेंट बिटवीन द टू डबल bonded atom double bonded carbon in trans 1,2 dichloroethene is the inversion center that denoted by small I line, because line drawn through it meets with two chlorine atoms or two hydrogen atom as shown in this figure. In this structure, two lines are drawn. The straight lines meet with the hydrogen atoms in opposite direction or meets with the chlorine atoms in opposite direction. Therefore, trans 1,2 dichloroethene has inversion center or point of symmetry. Next is alternate axis of symmetry or improper axis of symmetry of Sn fold, n fold. It is denoted by symbol Sn. N is the fold of alternate axis of symmetry or order of alternate axis of symmetry. To find out alternate axis of symmetry in molecule, two symmetry operations are carried out. First is rotation of molecule around an axis about an angle, followed by reflection in perpendicular plane. After these two operations, if molecule acquires indistinguishable configuration, then the axis along which rotation is carried out is termed as improper axis of symmetry or SN axis. For example, in trans 1,2 dichloroethene, if rotation is carried out, you will not get indistinguishable configuration. But if further reflection is carried out in perpendicular plane, then you will get indistinguishable configuration. The rotation followed by reflection in perpendicular plane results in indistinguishable configuration. Therefore, the axis that is C2 axis, the axis that is axis passing through the center of the molecule is improper axis of symmetry. As the rotation is of 180 degree, then 360 by 180 is equal to 2. The order of this improper axis of symmetry will be 2. It means it is S2 axis. It is S2 axis. Trans 1,2 dichloroethene has S2 axis or twofold alternate axis of symmetry or improper axis of symmetry. Rotation of the molecule around the molecular followed by reflection in the perpendicular plane results in indistinguishable configuration. In staggered conformation of a staggered conformer of the mesotartric acid, it also possesses S2 axis present as rotation about 180 degree followed by reflection in perpendicular plane results in indistinguishable configuration. Then it is shown here. It is a staggered conformer of mesotartric acid, rotation of 180 degree, and after this reflection in perpendicular results in indistinguishable configuration, and therefore this molecule also possesses S2 axis or twofold alternate axis of symmetry. Likewise, trans 1,3-dimethyl cyclobutane also has S2 axis. In this molecule, rotation of 180 degree followed by reflection in perpendicular plane gives indistinguishable configuration. Therefore, it is also possess S2 axis or twofold alternate axis of symmetry. Some more examples will be discussed here. In BF3 molecule, C3 axis is principal axis, which is present perpendicular to the molecular plane. This molecule also contains three C2 axes, which are present in molecular plane and passing through one of the boron and one of the fluorine atom. These C2 axes are regarded as subsidiary axes. Plane containing principal axis and passing through one of the subsidiary axes will be regarded as vertical plane denoted by sigma V. Thus, BF3 molecule possesses 3 sigma V planes that are shown below. In this molecule, C3 axis is there, 3 C2 axes are there, and plane that bisect the molecule in two identical halves that is passing through the principal axis and bisect one of the C2 axis is the sigma plane or vertical plane of symmetry. Sigma planes are denoted by sigma V. C2 axes are denoted by C2, and threefold axis of symmetry, that is the principal axis of symmetry, is denoted by C3. Molecular plane of the BF3 is horizontal plane of symmetry. It is the passing through the perpendicular to the principal axis. That is sigma H plane is also there in BF3 molecule. In nickel tetracyanide, nickel की बात यदि करें, it is a square planar complex. This molecule has C4 axis as principal axis. C4 axis, principal axis, along with C4 axis, it also contains C2 axes as subsidiary axes. 4 C2 axes are present in this molecule. C3 axes are present in the that is C2 axes are present in the plane. In the molecule, C4 vertical planes. In this molecule, 4 vertical planes present, which carry principal axis passing through 4 C2 axes. The subsidiary axes, these planes are shown below. The axis, this molecule is a planar molecule. The axis that is passing through the nickel and that is perpendicular to the molecular plane is C4 axis, as rotation of 90 degree around this axis gives indistinguishable configuration. Along with C4 axis, 4 C2 axes are present that are shown in this figure. Each C2 axis is present in molecular plane, and that is perpendicular to the C4 axis, that is the principal axis. Along with this, molecule has 4 sigma V planes that are shown, that possess C4 axis and bisect one of the C2 axes. The sigma planes are shown by sigma V in this figure. This molecule also contains sigma H plane. Which plane is sigma H plane? The plane that is perpendicular to the principal axis, or the molecular plane itself is sigma H plane. It also bisects the molecule in two identical halves that are mirror images of each other and can easily be superimposed on each other. As the BF3 molecule, PF5 pentafluorophosphorus has 3 sigma V planes, 1 sigma H plane. Each vertical plane contains C3 axes. Passing through one of the C2 axes. Horizontal plane present perpendicular to the principal axis C3 and passing through 3 fluorine atoms present in plane of the one in the plane and one of the phosphorus, one of the fluorine. Likewise, in benzene molecule, benzene molecule has C6 axis, C3 axis. C3 and C6 axes coincide with each other, and C6 is the principal axis. Along with this, C2 axes are present that are present in the plane, while C6 and C3 axis C6 or C3 axis is present perpendicular to the molecular plane. Here also sigma V planes are present, vertical planes are present that are shown in this figure. Benzene has 6 sigma V planes. Dihedral plane can be explained as plane containing principal axis and passes in between two subsidiary axes, that is denoted by sigma d, sigma small d. Dihedral plane. Dihedral plane can be defined as plane passing through in between two subsidiary axes containing principal axis will be regarded as dihedral plane, denoted by sigma small d. It is here wrong representation is there, sigma capital D, while it is sigma small d. In alene molecule, terminal hydrogen atoms present on the two different planes. Thus, 3 C2 axes are present in alene. C2 axis present on molecular axis will be principal axis, as it is passing through maximum number of atoms, C carbon atoms. 3 sigma d planes are present in alene molecule that are shown in this figure. Improper rotation axis or alternate axis of symmetry SN. The rotation axis regarded as improper rotation axis of symmetry if rotation around this axis by an angle followed by reflection in a perpendicular plane results in indistinguishable configuration. For example, in hydrogen peroxide, rotation of 180 degree followed by reflection in perpendicular plane gives indistinguishable configuration. Therefore, this molecule contains S2 axis. Improper rotation axis in octahedral SF6 molecule S4 is new symmetry operation, and it results from C4 it means rotation of 90 degree followed by reflection in sigma H plane, that is perpendicular plane, gives indistinguishable configuration. It is easily you can see in this figure that S1, S2, S3 F1, F2, F3 and F4 are present in the plane, same molecular plane, while F5 and F6 are present in perpendicular plane. Rotation of 90 degree, this is again wrong representation of rotation, that is 60 degrees shown here, while it is rotation of 90 degree. 90 degree rotation will along the axis that is passing through sulfur, and F5 and F6 gives you the shown structure. After reflection in sigma H plane, you will get indistinguishable configuration. Therefore, this axis is S4 axis or improper rotation axis of 4-fold. S4 coincide with S41. S42 is coincide with S42. Therefore, S42 is not considered as new operation in SF6. You can easily compare these two operations, that is S42. S42 means 2 times improper axis of symmetry. S42, that is rotation of 90 degree 2 times. It will give same results or same configuration. Therefore, S42 and C42 coincide with each other. Therefore, these both are not considered different operations, but these are the same operation. Therefore, S42 is nothing but it is C42. C43 is a new operation. C43, it means 3 times improper rotation operation along S4. It will give a new configuration, that is indistinguishable configuration to the original one. Therefore, it is a new operation. S44 coincident with C44, and hence it is not considered as new operation. The following conclusion can be drawn. SNN, that is equal to SNN, n is even. SNN, that is equal to SNN followed by sigma h, will be new operation if n is odd. Phosphorus pentafluoride, trigonal bipyramidal improper axis. We will discuss in next class.